All right, today we're diving into something seriously cool from Google. It's a new technique that tackles one of the biggest headaches in all of artificial intelligence. And it all starts with a kind of weird question.
Why is it that the smartest AIs on the planet are also kind of forgetful? I mean, these things can write brilliant code, they can compose poetry, but if you ask them to remember a really long conversation or read a huge document, they just hit a wall, a hidden fundamental limit.
And that limit, it's like an invisible memory wall. It's this massive bottleneck that just gets worse and worse the more we ask these AIs to handle, and it all comes down to one critical piece of their internal plumbing.
So the culprit here is something called the KV cache. The easiest way to think about this is it's the AI's short-term memory, its scratchpad. Every single time it generates a new word, it jots down notes here so it doesn't have to reread the entire conversation from the very beginning.
But here's where it all goes wrong. As the amount of information you're feeding the AI, the context gets longer, the size of that KV cache, that short-term memory, doesn't just grow, it absolutely explodes. As you can see right here, this is the memory wall in action.
Let's put a real number on this, because it's pretty wild. For a standard, common 8 billion parameter model, if you give it a 32,000 token context, which is, like a long report, that KV cache alone can gobble up over 4.6 gigabytes of super expensive, hard-to-get GPU memory, just for its working notes.
And look, this isn't just some nerdy technical problem. This is a real-world barrier that affects everything. It's why analyzing a whole book is so hard. It's why complex AI agents are so slow and expensive to run. It's a fundamental limit on what we can do.
But what if you could just change the rules? That is exactly what Google Research has managed to do with a new technique they're calling TurboQuant. And this isn't a small improvement. This is a breakthrough that just smashes right through that memory wall. To give you a sense of just how big a deal this is, Cloudflare CEO Matthew Prince, he called this Google's DeepSeek. He's talking about that moment when DeepSeek, a Chinese lab, dropped a model that proved you don't have to be a giant to compete. This isn't just another update. It's one of those moments, a real game changer.
If you look back at history, a lot of huge tech leaps come down to one unsung hero, compression. In World War II, it was compressing voice that made secure communication possible. In the 90s, JPEG compression gave us the visual web. Well, TurboQuant is that kind of leap, but for the age of AI.
Okay, so how on earth did they do it? What's the secret sauce here? Well, it's a really brilliant two-step process that combines some pretty elegant math with a very simple goal. Shrink everything down as much as possible with almost zero loss in quality.
And that process has two key parts. First, a method called PolarQuant does all the heavy lifting, the main compression. And then, a second technique called QJ comes in and does this super efficient cleanup job to make sure everything is still perfectly accurate.
Now, to get your head around PolarQuant, think about giving someone directions. You could say go 3 blocks east and then 4 blocks north. That's standard coordinates. Or you could just say go 5 blocks in that direction, right? It's magnitude and angle. That's what PolarQuant does. It converts the AI's data into this much more efficient format that's just way easier to shrink down.
Then comes the second step, QJL, and this is the magic touch for accuracy. After all that compression, it looks at any tiny leftover errors and represents them with just a single bit. We're talking basically a +1 or a -1. It's this tiny nudge that's just enough to make the final answer right again.
But the best part of this whole thing? It's completely training free. That means you don't have to spend a fortune retraining your giant AI model to use it. It's like a universal adapter. You can just plug it into pretty much any existing model, and it just works. That's huge.
Okay, so the theory is really clever. We get it. But what does it actually do in the real world? This is where the story goes from just interesting to absolutely stunning. Let's look at the numbers.
First, the big one, memory. TurboQuant slashes the size of that KV cache by a factor of 6. And let me be clear, that's not a 6% improvement. That is 600% more efficient. You can fit 6 times the information in the same amount of space.
And it doesn't stop there. It's also faster. On the most powerful GPUs out there, like NVIDIA's H100s, TurboQuant can speed up a key part of the AI's computation by up to 8 times. So it's not just smaller, it's way faster. All of this leads to a new magic number in AI compression, 3 bits. They can squash the data all the way down to just 3 bits per value and, here's the amazing part, with no real drop in accuracy. It's extreme compression without the usual compromise.
And they proved it. They threw the absolute hardest tests at this thing, like the needle in a haystack benchmark. That test is literally designed to see if an AI can find one single tiny fact buried in a massive sea of text. And even with its memory compressed down this much, it still found the needle.
So let's zoom out. What does this all really mean? Because this is so much bigger than just a clever research paper. A breakthrough in efficiency this fundamental could kick off a whole revolution in how we build and use AI. Just think about what this unlocks. For businesses, running AI suddenly gets a whole lot cheaper. For us, it means AI that can read an entire book at once. It means we're one step closer to having powerful AI that runs on your laptop, not just in the cloud. And it's going to make all those new AI-powered search systems faster and cheaper too. But here's a fascinating thought from one analyst. He said that when tech gets this much more efficient, we don't actually end up saving money. What happens is usage explodes. We don't just do the same old things for less money, we start doing brand new things that were completely impossible before.
And you want to know who noticed? The market. Big time. After Google announced this, the market value of companies involved in memory hardware reportedly dropped by about $100 billion. That is a massive signal that the industry thinks the rules of the game just fundamentally changed.
So the takeaway is pretty clear. The memory wall, one of the biggest constraints in AI, is finally starting to crumble. This breakthrough hit the AI's short-term memory, and you can bet others are already working on the long-term memory next. Which leaves us with a really exciting final thought. What impossible AI limit is going to be the next one to fall?